Assalamualaikum and hi. Today we want to present our group assignment for Mkw 3013. We are from group 10. In our slides, we will be presenting the financial market that we choose, solutions for question 1, 2 and 3, and our references during this assignment. The company that we choose for this assignment is Samsung Electronics. The daily stock prices data of Samsung Electronics Company for the year 2021 have three different states, which are upward when the share price increase, downward when the share price decrease, and remain same when the share price gets unchanged. We got the stock price data from the Yahoo Finance website. We picked the data of Samsung Electronics from 4 January 2021 to 30 December 2021. From the data, we only using the adjacent close data only to plot the time series of the historical stock prices. We can use the data to plot the graph using Microsoft Excel. From the data of the closing stock price of Samsung Electronics, we observe that the next day price is either in the state of upward, downward, or remain same. These states are obtained in Microsoft Excel using a function. The following table represents the frequencies of the states. The frequency of upward is 110, downward is 125, and remain same is 12. The total of the frequency is 247. The required initial probability vector for upward is 0.445344, downward is 0.546073, and remain same is 0.04x5x3. To answer question 1c, we know that the state space of our Markov chain model is S equal to upward, downward, and remain same. In order to construct a transition probability matrix, we first have to find frequencies of transitions from one state to another state, such as upward upward, upward downward, upward remain same, or downward upward, downward downward, downward remain same, or remain same upward, remain same downward, remain same, which are obtained by using the COUNTIF function in Microsoft Excel. With the obtained frequencies of the transitions, we now can construct a transition probability matrix by calculating the probability of each state moving to another state. The calculations are made by dividing the frequencies each of the state moving to another state with the total of the state as shown below. As an example, for the state upward move to state upward, the calculation is 53 divided by 110 equal to 0.481818, and the other probabilities calculated one by one. From that, we finally obtain the transition probability matrix. For question 2, the long-term behavior of the share is obtained by determining the higher order transition probability orders reaching the stationary probability distribution of Samsung Electronics by using calculation. The expected frequency of visits the stock prices of Samsung Electronics make to some specific state starting from another state of the system in different steps is obtained. Expected number of visits to particular state is obtained in order to know the expected time. The moving particle stays in certain states. Here, for Samsung Electronics, the number of visits to a particular state using the formula defined in the following matrix. The expected first reaching time to the state of upward from the state upward reveals that the chain makes a visit to the state of upward, on average in 2.2 days or approximately 2 days. Next, the expected first reaching time to the state of downward from the state downward reveals that the chain makes a visit to the state of downward on average in 1.9 days or approximately 2 days. The expected first reaching time to all the states can be obtained. Finally, we can observe that stock prices will reach to the state of remain same starting from the state of remain same on average in 20 days. It also represents that the stock price are extremely random and volatile in nature as no stability is found. Last but not least, for question 3, the chains are reducible since we can go from any state to any other state in a finite number of steps, and each state can communicate. In other words, the Markov chain is said to be irreducible if it has only one communicating class. The chain is also aperiodic because the chain returns to the state only at multiple of integers larger than 1. For question 3b, limiting distribution is independent of the initial state and is an asymptotic distribution. For the states in Markov chain, then there is limiting distribution. In this case, as we take the limit of n equal to infinity, every other term in P is 1, so the limit exists. As this Markov chain is irreducible and aperiodic, so the stationary distribution is limiting distribution. Stationary distribution depends on the initial distribution. Once we use limiting distribution as the initial value of the Markov chain, we have stationary process. Here is the list of our references during this assignment. That's all from us. Thank you.